Okay, this is Algebra 2, Lesson 6. We're going to talk about decimals. How do we solve equations with decimals? Decimals are no different than whole numbers or fractions. The only difference is decimals. And what are your rules for doing decimals? But we're going to look at it a little differently, a different approach. We could either say, okay, basically, I do it the same way. I treat this as a whole number, except for it's a decimal, and I use my decimal rules to add or subtract or multiply or divide. Or you can say, what if I want to deal with all whole numbers and I don't want to deal with decimals? Well, you can. If we begin by multiplying every term, remember, what we do to one side, we must do to the other side. If there is more than one term on each side, we must, when we're talking about multiplication or division, not addition or subtraction, when we multiply or divide both sides of the equation, we must multiply it by every term in the equation. This has two terms. Remember, a term is separated by a plus or a minus. These are two terms. They are not like terms. We learned that the other day, so we cannot combine them, because this has a variable of x to the first power. This has no variable, or we can say, remember, it's an implied x to the 0 power, but we said you have to have the same variable or variables raised to the same power. If this is to the first power, this would be to the 0 power, which makes them different. So let's multiply both sides of the equation. When you put parentheses on each side, then that will help you to remember you've got to do every term. Let's multiply by 1,000. Well, because of my parentheses, I says I have to use the distributive property, yes? When I multiply by 1,000, 1, 2, 3, this simply becomes 3x. This becomes 400. Yes? Plus 400, and this becomes 2,050. Now, we have whole numbers, so now I can just simply solve minus 400 minus 400. 3x equals 1650 divided by 3. Did I do bad math? X equals 550. Simple as that. Yeah? So, many people use the word decimal fraction to describe a number that is an internal decimal point. This is because such a number, let's look at this one, excuse me, 2.0413, we can write it as a fraction by putting 20413 all over 10. You can't see it, I'm going to write it up here. We could put 20413 all over 10,000. Why? How do we get that number? Well, we look to see what place this is in. This is called the tenths, hundredths, thousandths, 10,000th place. Therefore, you're going to put it over 10,000. That's simply what a decimal is. It's a fraction divided. If you take a calculator, you do 20,413 divided by 10,000, you're going to get 2.0413. So don't let that confuse you. Simply, a decimal is a fraction divided out. That's all it is. So let's look at example 6.2. So again, we can use a fractional equation with decimals. The students found that 0.015 of the teachers, so a fraction, just like we did in our previous lesson, we said 1/4 of the teachers were either brave or completely fearless. If 300 teachers fell into one of these categories, how many teachers were there in all? So first of all, what is our fraction? So remember, we have fraction times of equals is, or fraction times whole equals part. I like this one because I can see it better and it makes more sense, but this one works just as fine. It's the same thing. So our fraction is 0.0015, right? Because we said simply a decimal is a fraction divided out. So this is your fraction here. Of the teachers were brave or completely fearless. If 3 teachers fell into one of these categories, how many were there in all? So we said times teachers, and we said if 300 teachers fell into one of these categories, that they were, right, we said this many this percentage or this fraction were brave, if 300 fell into the category of brave or fearless, how many were there in all? How many teachers? So you want the total. So now we just simply divide by both sides by 0.015, and we get T. If you use your calculator, it's going to give you 20,000 teachers. Does that make sense? Okay, let's look at another one, 6.3. It says, an analysis of the old woman's utterances show that 0.932 were vaticinal. If she spoke 2,000 times during the period in question, how many utterances were not vaticinal? Well, I don't like the words they used. They could have simply said, an analysis of the old woman's words showed, okay, again, that her fraction or her decimal was 0.932. Okay, this is a fraction of her words, so were prophetic. Okay, if she spoke 2,000 times during that period, how many utterances were not prophetic? Okay, so this is how many were prophetic. And we said, what was her total words that she spoke? Well, she spoke a total of 2,000. And this would give us how many, the part that was left over, or how many were prophetic. Okay, I'm not going to spell this out. Okay? But the question asks us, how many were not vaticinal, which means prophetic, prophetically speaking. All right? So we have to take, this is how many were, so we have to take were not. They have to equal 1. Remember, 1 is a whole total. So we would have to do 1 minus 0.932. Oops, this is a 2. Okay. For any of you who forgot how to borrow, go back and remember. Or we can do that if you need help. So this is the percentage or the fraction, or this is the fraction that were not prophetic, or the words that were not spoken prophetically or vaticinal. So we're going to take this 0.068 times the total words to get the part that were not. Yes? So now we simply have 136 equals P, or you could call it not V, NV, which is what it was. And there's your answer, because you simply just solve for, this would be P, or whatever variable you want to assign to it. I assigned it P, and that's your answer. Okay? You have to remember, because if they give you a fraction of a total as this, and they want to know how many was the opposite, were not. They say if, you know, 3/4 of the students were girls, how many were not girls? Well, if 3/4 of them were girls, how many are not girls? Or they say 0.75, they want to know how many is not girls. We'd have to subtract this from 1, which would be 0.25 were not girls. That is the fraction of the whole that you're going to take to get the part that were not girls. So be careful with that when you're doing those questions. So assume that it's going to be this is your fraction times the whole to get your part, because they may ask you for this. All right. So now we're going to talk about consecutive integers. We kind of touched upon this on Algebra 1. So basically, we said to designate an integer, we can say n, and then n plus 1, n plus 2, n plus 3. Let's see if that works. 1, 2, 3, 4. Do you see that? These are consecutive integers. Consecutive means in a row. Integers, yes? What if I want to do odd integers? It's going to be n plus 2, n plus 4, n plus 6, dot, dot, dot. So this would be 1, 1 plus 2 is 3, 1 plus 4 is 5, 1 plus 6 is 7. Aren't those consecutive odd integers? Yes. And to do consecutive even integers, we do the same thing. n plus 2, but instead of starting with 1, you would start, n would be 2, because you want even. And it would be n plus 2, n plus 4, n plus 6, and so on and so on. So what does that matter? Well, let's do a word problem. Let's do the example. The example says, 6.4, it says, find 3 consecutive integers such that 5 times the sum of the first and the third is 16 greater than 9 times the second. What does that mean? Okay, first of all, find 3 consecutive integers. N consecutive integers. N plus 1, n plus 2. So this is integer 1, 2, 3, right? So let's call them integer 1, integer 2, integer 3. I'm just renaming them. That's all I'm doing up there. Okay. Now it says find such that 5 times the sum of the first. So 5 times the sum of the first and the third, this is why we use subscripts, okay, is 16 greater than 9 times the second. So it's 16 more than 9 times the second. So 9 times n2, but it's 16 more. So this is 16 more than that. So I'm going to subtract 16, so then they're equal, or I could add 16 to that side. Does that make sense? That's where it gets tricky. You have to think. It says this, instead of reading the whole mumble jumble, you've got this together. You say this is 16 more than this. Then you're going to go, oh, just like you said, if this is me and this is you, I have 16 more dollars than you. Well, you would take my amount, subtract 16 to get yours, yes? Or you would take your amount, add 16 to get mine. So that's how you can look at this. So we simply, before we distribute, I'm going to go back and say, what is n1? It's just simply n plus. What is n3? N plus 2. Are you with me so far? That's why I use the subscripts. I've said I need 3 consecutive integers. First one's going to be n plus 1, n plus 2. Then I'm going to start with, this is n1, this is n2, n3. Then I set up my problem. I said 5 times the sum of the first integer plus the third integer, so the sum of those two times 5 is 16 more than 9 times the second integer. So now I'm going to have n. What is n2? N plus 1. So they're all the same, because right now you really have 3 different variables. Even though they have the same letter, because the subscripts are different, it now means something else. But once I replace them, I have all n's now. So now I simply just distribute. Put this down a little bit, have a little bit of it later. So 3 terms. So this is going to be multiplied times 3 things. 5n plus 5n plus 10 minus 16 equals 9n plus 9. Combine like terms, so I have 10n minus 6 equals 9n plus 9. I'm going to subtract 9n from both sides, and I'm going to get n minus 6 equals 9 plus 6 plus 6, n equals 15. So n is 15. So my 3 consecutive, now I can go back and go 15, 16, 17. Yes? Oh, I'm sorry. It asks for even integers. So well, we just did integers. So that's what you would get. It said even integers. So this should have been n plus 2, n plus 4. But we're just going to change that problem to just integers instead of even integers. Okay, let's do one more and then we'll be done. It says find 4 consecutive, for example 6.5, find 4 consecutive integers such that 5 times the sum of the first and the fourth is greater than 8 times the third. So first of all, we're going to see what they want for it. They want 4 consecutive integers. So they want n, they say consecutive integers, not even or odd, so it's back to what I used earlier. n plus 1, n plus 2, and n plus 3, and we're going to call this n4. With me? So now it says find 4 consecutive such that 5 times the sum, so the sum means you're going to have two things added together. The sum of the first, we call that n1, and the fourth, n4, is 1 greater than 8 times the third. Okay, we said, now let's go back before we do that, more or less than the third. We said 5 times the sum of this, okay, is 1, the number 1, greater than this. So this is 1 more. So we have to subtract 1 to equal that, or add 1 to that to here. Again, it's like me having this much money, and I have $1 more than you do. So you take my total minus 1 to get your total, or take your total, add $1 to it to get my total. So if you change the words and think of it that way, then it becomes more clear, oh, it's minus 1 on this side or plus 1 on that side. Either one will work. It doesn't matter. So now we're going to go back and we're going to substitute. Yes. So we're going to have 5 times n, n1 is n, n4 is n plus 3 minus 1 equals 8 times n plus 2. Does everybody see that? Pretty simple. Now we just distribute. 5n plus 5n plus 15 minus 1 equals 8n plus 16. Basically, I'm using the distributive property, and however many terms you have inside that parentheses is how many times you have to distribute this number outside to it. Okay, so I'm going to combine like terms. 10n plus 14 equals 8n plus 16 minus 8n minus 8n. 2n plus 14 equals 16 minus 14 minus 14. 2n equals 2 divided by 2 divided by 2. N is 1. Okay, that's what n is equal. Okay. However, now we have to go back and put. They asked us. The question is, find 4 consecutive integers. Well, I've got 1. Okay, because n is 1. 1 plus 1 is 2, 3, and that is my answer. 1, 2, 3, and 4. That's it for lesson 6.